Alright, this is demand part 2. This video will go by much quicker than the other video. We got cut in half there. We were talking about elasticity and inelasticity. So, as I was saying, the more substitutes there are for a product or good, the more elastic it's going to be. It's going to be very sensitive to changes in price, meaning people will refuse to buy things if it's too expensive, right? Or if all of a sudden the price drops drastically, everybody's going to go buy it. But one thing that doesn't change is inelasticity. Demand is the same no matter what. A good example I was saying was salt, and we'll talk about salt a little bit. No matter what, people need salt. And there's not really any substitutes for salt, and we'll talk about why in just a second. I don't want to ruin the story that goes with that. But another example would be water. Now you're thinking, well, what about juice and soda? Well, that has water in it too. So it's a crucial ingredient for us to live. Gasoline for your car. Now, yes, there's alternatives, but gas is inelastic to a certain point. If prices do get too high, what you do see is people refusing to drive and finding other alternatives. That happened a couple times during the recession from 2008. All right, so a couple of rules with the math. If your calculation is greater than 1, it's elastic. If it's less than 1, it's inelastic. If it's equal to 1, it's something called unit elastic. Now, I'm not going to go through and explain every detail of how do you figure out if something's elastic, but we're assuming you have numbers. And to find the elasticity, you have to figure out, or you take the percentage change in quantity demanded, and you divide it by the percentage change in price. How do you find percentage change? Well, it's actually another formula over here. You take the original number, so usually it's the first number, minus the new number, but divide it by the original number. So whatever number you get here, you're going to divide by the original number, and then you times it by 100. So that tells you right there. So you have this chart here, and yes, unfortunately, over time, this thing has kind of gotten weird. You have price on the y-axis and quantity demanded on the x-axis here. And we're looking at two different price points. Now, everything always depends on price. Price is always what changes, not the demand. You can change demand, and that's breaking the law of demand. That's something called artificial demand. You see that with like stuff like Kardashian stuff, where you have a celebrity promote something, you know, especially with Jordans, they'll have like a limited supply, and that's actually artificial supply too, to create an artificial demand for things. And you have anything that's a trend, like the fidget spinners a few years ago, that's artificial demand. Anyway, you can see here that price has decreased from $4 to $3. So that's what we're looking at, these 2 points. So you can see here 4 divided minus 3, that's 1. Divided by 4 is 0.25 times 100, you get 25. Then you have, you go down to 10, because the 4 was with the quantity demanded of 10. 10 minus 20, the new number, that is negative 10. However, negatives are thrown out in these equations, or in these scenarios. So throw them out. 10 minus 20 is 10 in economics. Yes, there you go. Don't try that with your math teacher, though. So that's 10 divided by 10. That's 1 times 100 equals 100. 100 divided by 25 equals 4. 4 is greater than 1, so we know that this item, whatever it is elastic. So let's move on. Inelastic. And yes, you can see here, people have figured out, oh, well, if I just look at the shape of the line, that'll tell me everything I need to know. Don't always rely on that. That can be very bad. So here it's going from 6 to 2. So 6 minus 2 is 4 divided, 4, sorry, excuse me. You divide it by the original number. 4 divided by 6 is 0.666 repeating. Times it by 100 and round, or 67, right? You could put 66 if that makes you feel better. Either way, you're going to get a similar answer here. The same thing, the demand is increasing from 10 to 15. 10 minus 15 is in normal numbers -5, but no negative, so it's 5. 5 divided by 10 equals 0.5 times 100 is 50. And this is when you need a calculator, because I can't do this kind of math in my head. 50 divided by 67 equals roughly about 0.75. That's less than 1, so we know it's inelastic. All right, so what are some factors affecting elasticity? Okay, so we've got substitutes, importance, necessities versus luxuries, and change over time. So I already explained the substitutes one. If there are more substitutes, then people are going to react by jumping to the substitute, right? The price of soda becomes $20 a can of soda. People are going to jump to drinking juice. It's just kind of how it is. So if there's a lot of substitutes, it's going to be super elastic, meaning we, the consumers, are going to jump to a different product. Relative importance. So how much of your budget do you spend on the good? This is a good one for gas. To explain, gas is super important, right? And most of us use cars to get around, and even the ones of us who don't usually take a bus. So gas is important to our lives, and that affects, or even if you take the bus, the price of the bus fare may change. Well, not a school bus, but I'm thinking city bus. Necessities versus luxuries, excuse me. So whether a person considers a good to be a necessity or a luxury has a great impact on a good's elasticity. So water, right? Everyone needs water to live. So that's a necessity. However, yachts, right, like the boat. Does everyone need a yacht? I know some of you are nodding your heads like, yes, you need a yacht. No, you don't. So that's a luxury. Now I'm using two extreme examples, but certain clothing brands, right? You don't necessarily need, right, the Michael Kors brand or the LeBron James endorsement. You don't need that. You need your basics, though. Change over time. So this was my story. So sometimes a good starts off as an inelastic, and then over time, because there's more substitutes, it becomes elastic. So sugar and salt are very good examples of this. So I said salt was inelastic, but once upon a time, sugar used to be inelastic too. It only had 2 substitutes, and that is molasses and honey. I don't remember what molasses is made of. So, but sugar, there's a joke with that. Sorry. But sugar was actually an essential ingredient in a lot of foods. It still is today. You may not realize it, but it very much is. But even from everything from making bread to curing meat back then, remember, things didn't always taste good. So you added sugar when you could. And sugar was kind of rare. So sugar was inelastic. It didn't have a lot of substitutes. Fast forward to post-World War II. We're in the Cold War, space age, and scientists are, instead, they don't want to send whole packs of sugar, so they start looking at liquid sweeteners, right, to sweeten food. And lo and behold, they find their first artificial sweeteners. However, it's not commercially available until the 1970s. And the first time you see anything artificially sweetened is through Tab soda, a diet soda. Tab is still around. Eventually, the Coca-Cola company takes that and makes the classic Diet Coke, right? And the rest is history. Eventually, you start seeing Sweet and Low packets at restaurants and artificial sweeteners. And then by the time you get to the 2000s, you have Splenda, you have Stevia, and you have all sorts of different brands. Salt doesn't have a substitute, though. Sodium chloride. That's it. There are some medical substitutes, however, they're very expensive to produce. But if one day they become cheaper, then yeah, you might start seeing salt become elastic, just like sugar. I think I should be done. Yep, we skipped this in class. And that's it. That's my TED Talk. I'm kidding. But if you have any questions, please, in the discussion, let me know, and I'll be happy to answer anything. Have a good day.